So basically that's a very simplistic view of the water cycle. Large water cycle, small water cycle which is over land, and that's really what we're dealing with. I've drawn a very pretty little blue arrow in there which is basically indicating that's the number that we've impacted with our changes, what us white fellas have done, and this number here. And the other thing we've got to do is try and address this massive amount of energy which hits the earth every second. If you think of the lights at the MCG, if you think of an LED light bulb that you've got in your bathroom, that's how much all of humanity uses. So just think of that comparison. That's the comparison of what hits the earth at every. And just think if we sat out there and just let that happen, we'd be fried. So something is there to dissipate that energy, and we've got to try and help that to happen through landscape rehydration. One of the key things we do in landscape rehydration is we try and hold the water up where it falls and use it at that location. So there we've got just a simple at the bank with a little sump and a sill, and that water flows out onto vegetation. Instead of the water going straight down the slope there, it's held up in the landscape. Yeah, so we can use various methods to try and hold that water up in the landscape, and that's really what we're about. And that's all about supporting what was talked about this morning, really improving soil health. So that's an example from Dave McFall down near Kojonup. He's actually an organic farmer. You can see the massive root growth on his crop. That was taken last August, I think it was. Obviously it was a good, nice wet year, and that's through managing the water in the landscape, holding that water in the landscape and building that soil carbon, the soil organic matter, which allows the biology to build as well, which is exactly what you've been talking about this morning. So that's just another thing. And I guess Terry was talking about that spiral upwards. So what we want to try and do is convert that spiral downwards to a spiral upwards and have this building system. So once you've got the ingredients in there, the water, the organic matter and the biology, that's a self-perpetuating system. And now I've used a big word. So we get to that spiral upwards. So it's gradually building and building and building. And so as you add more water and more plants, it has the capacity to store more water and have more organic matter, and that just keeps building itself up. And that's what we're about. So what are the changes in our landscape, in our climate, that have really brought on the reason why we need to do the rehydration? And one is clearly there. That landscape would have looked like that 200 years ago. And I'm not even sure where I took this photo, but it was a few years ago. But yeah, you can see it's all cleared. So we've replaced that perennial vegetation with an annual system which only grows over maybe 3 or 4 months of the year. So that other 9 months of the year is basically wasted. Nothing's happening. So that energy is not being dissipated, and that water is allowed to just go wherever it wants, and it doesn't get used up in the landscape. Through that clearing, it's also changed the albedo, which is like the reflectance of the earth. So in the past it would have been all like that, dark. Now it's a lot like this, pale. And we all know that a black surface absorbs energy or heat, and a white surface reflects it. You go on a black beach, hot sand, white sand, it's hot on the air above the sand, or the sand gets hot as well. And that changes a lot in terms of that energy dissipation. So if it's absorbing the energy in the vegetation, the process there with moisture, with water, because when water evaporates, it actually stores heat in the air, called latent heat. And then that dissipates back out in the atmosphere and up. So that's one way of dissipating the energy. So if we don't have that perennial system here, so in summer when it's hottest, we're not dissipating that energy. And I'm sure all of you have been out into a paddock in summer and it felt like you're baking. Another key factor with the changes that we've done in WA, and I guess you're all probably familiar with this, is we have increased runoff, particularly in those middle-sized events, 30, 40, 50 millimetres in a day. The landscape had evolved to basically absorb that rainfall, and you would have seen very little runoff in those events and under natural conditions. But since we've taken all perennial vegetation away, those events now start generating runoff. You can tell this paddock's eroded because all there is sand and sediment which has been deposited from a little bit further up slope. And there's some deposition there, but there's also scouring in the rows between the where the crop's been put in. And where does that lead to when you get down a little bit further in the valley floor? When you get, as we all know, we've got such low slopes, particularly if we go further out that way. The valley floors are very flat, very low grade, so the water doesn't move and it sits there. So you can see there that creek line, and it's not a major creek line, it's in winter, it's got water just sitting there in the paddock or in that creek line, and it's recharging and it raises water tables. And you all probably know this because it's probably been drummed into you for the last 20 years. But you can see the signs: bare soil, high water table, evaporation of salt, scalding, and you can also see the water sitting there, and the species growing there, that's Puxinalia. So we all know that's salt tolerant. We all talk about the decline in rainfall and the fact that it's climate change, and I believe it's not just climate change. So this is just the record for northern. I couldn't use the Murest record because there's a huge gap in the middle of it. But you see from about 1975, I just picked that date and you'll see the reason why in a minute. That line there is the average. So that's the average before that time, and that's the average after. So you can see there's a 30 or 40 mil drop in the rainfall over those two periods. And this is just a way of presenting the data to just show the change over time. So as it goes up, it's indicating the rainfall's more than your average, and as it goes down, it's less. You can see the peak, and that's around that 1970-75 period. The green line is the winter rainfall, the red line is the summer rainfall. You can see, so most of that changes in the winter rainfall. And I'm probably preaching to the converted again because you probably all know this. You can see there, the big impact is in May and June, and you all know that because particularly if you're cropping, you used to seed in April, and now you're seeding in late May or whatever, where you're dry seeding. Restoring the water cycle is about redressing that 12% or the 14% of evaporation and that 12% of water that went back down the ocean. So the 14% is the evaporation that's coming from vegetation, so we've reduced that. And then the 12% we've increased is the surface water runoff. So we need to try and get those figures back to what they should be. So obviously we've seen different in WA, as I showed before, one of the classic symptoms, salt scald, and that's actually not in the creek land, it's just on the floodplain. And then you've got the massive, great big broad valley floors, which are bare soil and sandfire, and I'm sure many of you have seen that. The other one that many people would have, particularly further west in the Wheatbelt, is hillside seeps. And often that's actually not so much salinity, but it's waterlogging is causing the problem. And that was actually the case in this one. It looks bare, and the white looks like it's salty, and it is a little bit salty. At the end of summer, there'll be a bit of a salt crust there, but it's mainly waterlogging that's causing the damage. And that's, again, through just upsetting that water balance. These are from Murest, just to show a bit more of that waterlogging. So top end of the creek line, that's the ridge there. So right up near the top of the catchment, and we're getting waterlogging. And this is down lower, so that's the Avon River along there. The slope there, all the black or dark coloured is waterlogging, and I'm sure you recognise the signs. And that strip there is, I reckon, is an old prior stream. So there'll be a bit of a sandy lens through there, and the water's just going through there, and it's waterlogging. The other thing is that happens is we get erosion. And as I said before, the landscape had evolved to cope with those 30, 40, 50 mil events by just absorbing it in the landscape through vegetation. And then we've taken that away and it's running off. And the channels that we had, they're not really channels, they're just a very broad dish valley floor. We didn't have those little flows, so we didn't have to cope with them. But then once we put those flows in there, nature has to say, oh, I've got to deal with them somehow, so it cuts a little channel. And that gradually gets bigger and deeper and deeper. And then you get this. So this is an active one. And this one's from Murest as well. So down the bottom of that same catchment that I showed previously. You can see that the natural bed would have been about there, and it's cut down, and it's not massive, but it's a metre down, it's cut into the profile. And then the same incision happens on the valley floor, problem for us, particularly for anyone who lives further west in the catchment. You get these small incised channels which have never existed before, and they actually transfer the salt further downstream. So the natural system, the salt would have just been there underground. We've released it by raising the water tables. Surface water comes down, mixes with that, takes it further downstream, stores it somewhere else. The next event takes it the next step down. And that's why people down the southwest in the Blackwood, people down the coastal plain of the Avon, don't like us because we chuck our salt down there. What are the generators of erosion? Everyone would have seen this. It's really good when you can see it from the air like that. Stock tracks, that's a stock track. And you can see it's already, the water's run down there, it's been concentrated and running down there. That was a track, a vehicle track. And it's up on the ridge, and it's now about 1 metre deep. So yeah, let's go outside.